All right, folks, we are going to be getting into section 6.3 today, which is graphing sine and cosine functions. And I'm not going to waste any time. Again, we're going to get right into looking at how we deal with this. When we talk about sine and cosine functions, these are an example of a periodic function. And I think we need to deal with what that is first. Just to be clear, when we talk about a periodic function, what we're talking about is a function that over a length of time, distance, whatever it may be, repeats itself. So in other words, it begins at a certain point, it ends at a certain point. That ending is the same place it began because the next cycle is going to start right there again. So what does that look like? Well, we could have a function that does something like this. If we had, let's draw another color. If we have a function that does this, goes here, there, and we'll pretend those are exact copies of each other. Each of those hills that I'm drawing, they're a little wavy, but let's assume they are. And so this is 1, this is 2, 3, 4. All right, so let's say we have this. And when we look at this, this graph starts at 0 and a height of 0, goes up, then down, back to where it started at 1. And then this repeats itself. I could slide this way, then slide it again, and I would get that same repetitive shape. All right, this is an example of a periodic function. This would have a period of 1, or period equal to 1, because this shape repeats itself. It goes from its beginning to its end, which is back at the beginning again to the next one, and starts again in a length of 1. All right, again, that could be 1 second, 1 minute, it could be 1 foot. When we talk about period, generally we're talking time though. But again, you'll see we're going to deal with it with sine and cosine in a different way. All right, so let's do another one. If we have another graph. All right, and let's draw this one where we start here. And I'll try to make this as precise as possible with the tools I have here. So we have this graph, and it will say it continues on, right? That's one thing I should have probably done in this, that this continues on forever, all right? This, we want to say, is this a periodic graph? Let's say this is the value of 2, 4, 6, 8, 10, 12. All right, if we look at this graph and we say, all right, is this periodic? Well, it starts here, right, in the Y position here. It goes forward, down, across, back up, and now it returns to its starting point. Once it does that, we want to look and see, does it repeat the same thing? Does it go over, down, across, up, back to its starting point? So it does. We could take this and keep sliding it. So this is a periodic function. What is its period? Well, how long does it take to repeat itself? Well, to do 1 full cycle, it takes 4, whatever 4 is. And then it starts to repeat again. So its period is 4. All right, that's the idea of a periodic function. It's something that repeats itself in a certain length. All right, so normally length of time or some measure that we apply to it. All right, so now let's move forward and talk about this in terms of the things we're used to, which are things like our sine and cosine. So let's do y equals sine theta. Now I know many of you have gone over this in years past, and I just want to give you like kind of a fresh start at this and show you how I think of it and how I approach it. So first thing, if we think of our unit circle, let's redo that one. All right, let's do a bigger one over here. If we think of our unit circle, and let me try to give it some nice axes that are relatively accurate. All right, so if we have that, when we go around our unit circle, we start at 0, right? And at 0, we know the position is 1, 0 of this point, right? As we rotate around this circle, we get up to here. This is pi over 2. And the position of that is 0, 1, right? We get over here. This is pi. And our position is -1, 0. And down here, we're at 3 pi over 2. And our position is at -1, or I'm sorry, 0, -1. 0, -1. And then we get back to 2 pi, which again has position 1, 0. And then it starts to repeat itself. So you see how this can be considered periodic in a sense, is that if we think of the values, whether they're cosine or sine, and remember, any point on the unit circle has position cosine theta, sine theta, right? So when I talk about the sine at 0, all right, 0 radians, the sine would be 0. Then I go to pi over 2, the sine is 1, right? It's this y value here. When I go to pi, the sine is 0. When I go to 3 pi over 2, sine is -1. When I get to 2 pi, it's back at 0 again, starting the same cycle over. We can keep rotating around this. So we can go both directions, backwards or forwards, and you're going to see a repetition of that. This is a periodic function, all right? Now, how do we graph that? We graph it a little differently. Let me move this down. Whoa, that's not going to move it down. That is just going to draw all over it. All right, if we move this down and maybe shrink it just a touch. All right, so we're looking at this while we're seeing this. I want to do both at once here. Okay, so now, if we want to graph this, I'm going to put those same points here on the graph. We start at 0, we go to pi over 2, then to pi, 3 pi over 2, and 2 pi. And then we could continue on if we want to. What we're looking at here is this is our theta instead of x. And this is our y value. This is our sine value, if you want to call it. This is sine theta, or our y value, okay? So where do we start? For sine, we start at 0. 0, 0 is where we start. At pi over 2, we have a value of 1. We'll make this 1. We have that value of 1. At pi, we have a value of 0 again. At 3 pi over 2, we have a value of -1. So 3 pi over 2, we're down here at -1. And at 2 pi, we're back at 0 where we started. Now, what would happen if I continue this on? At the next one, which would be what? 2.5 pi or 5 pi over 2, we would be back going to 1, right? 5 pi over 2 would be up here. We'd be up at 1 again. So what happens is this graph does a nice curve where we do this. I'm trying to draw this as nice a curve as I can. And it ends, I should say, it goes on, it does not end. We draw arrows at the ends passing through that last point because this continues on. If I went backwards, I would be at negative pi over 2 over here, right? At negative pi over 2, that would be down here. I would have a value of -1. So this continues on in each direction forever because we can rotate clockwise or counterclockwise and it'll keep going forward because at 5 pi over 2, it's back at 1. At 3 pi, it's back at 0, right? Each multiple of pi, it's going to be at 0. Each multiple of pi over 2, the odd multiples of pi over 2, I should say, it's going to be alternating between 1 and -1. All right, so this graph just repeats itself again and again. And this is your basic graph. All right, we're going to look at how we're going to deal with this in a minute, but I want you to just keep in mind the periodic nature of this and the position and the points that we just did. All right, because we're going to do the same thing now for cosine. Oh, well, we should talk about one thing. Going back here, I didn't mention the one key point here. What is the period of this function? Well, again, it starts here. It comes back to where it started, but it doesn't do the same thing again by going up. It comes back to where it started, goes down, so we can't consider that the end of the period. it comes back to where it started, going back up again, repeating the same shape that we see here. So its period is 2 pi. All right. And when we talk about that, or when we talk about periodic functions, it's always important to know their period. So this one has a period of 2 pi. All right. And one thing I want you to see also is that it alternates between 1 and -1. It never goes above or below that. We talked about that in our unit circle stuff, but now you see it more visually, that it keeps bouncing between -1 and 1, right? All right, so now let's go forward. And let's do the same thing again, looking at y equals cosine theta. With y equals cosine theta, again, I'm going to do a nice circle, create a unit circle for us real quickly so that we can talk about the values of cosine as we go around. When we're dealing with cosine, again, we start with our 0. We have pi over 2 up here, pi, 3 pi over 2, and back to 2 pi, right? So we have those. Now, again, position-wise, we want to talk about the position of these points. This is 1, 0. This one is going to be the point 0, 1. This will be -1, 0. This will be 0, -1. And we're back to 1, 0. So now what are we worried about with cosine? Cosine is that x value, right? Any position on the unit circle is cosine theta, sine theta. So we're talking about the values that are the x's. And again, these 5 key values, 0, pi over 2, pi, 3 pi over 2, 2 pi, are going to be the ones that help us draw all our graphs. All right, so we're going to use that again. And I'm going to paste that in. And again, I am going to shrink it a little bit. And move it around. All right, I think we're good there. And all right, so let's do this. So now, looking at this again, we're going to use this as our theta. This is going to be our cosine theta, right? So with cosine theta, where does it start? At 0, it's a value of 1. So it starts up here instead of at the origin like our sine did, right? Now we go to 0. And then back here, we go to -1. So this was, again, pi over 2. At pi, we're at -1. This was at 1. So we're down here. Then at 3 pi over 2, we are back at 0. Again, that's our x value. And at 2 pi, we go up to where we started again, and we're back there to begin again. Now, think of what happens next. If I went out to 5 pi over 2, it would be coming back to 0, wouldn't it? It would be coming down to here. So same thing here. If I go to -pi over 2, it would be coming down to 0. So what we're going to do with this graph is we're kind of think of it, it was coming from here. So it comes up through here and then down to here. So I'm going to put an arrow there because it's going to go on forever that direction. And then it kind of goes down to this, making that nice arc. All right, and then it's going to go up here and back down. And then again, it was going back down. I don't need to go that far. As it goes through 2 pi, it is going back down. So we have an arrow at that end. These arrows are very important, guys. I want to make sure you understand whenever you draw a graph of this, with some exceptions, which we'll get into, we're going to put arrows. If we're just drawing the graph of a function, sine, cosine, then we are going to say it goes on forever with those arrows. All right. So we have, again, this situation. Now, this should look pretty familiar because it's really the same shape. I mean, if you look at what we had with sine, sine was starting here, going up here, down to here, and doing this, right? It was doing this kind of thing. This was our sine. So what do we have? Cosine is just shifted 90 degrees. All right, or you can think of sine as being shifted of cosine, however you want to think of it. They're just 90 degrees kind of out of sync, right? but they're the same shape. They have many of the same characteristics. They just are shifted, right? It's the same type of shape. And please, guys, I'm going to say this a couple times throughout the year. Don't draw these this way with sharp points. I'll have people draw them that way all the time, and that just gets a big no when we grade it. All right, draw them as a curve. You can practice this when you do it. All right, so we have this again. Again, I want to discuss what is the period of this function. Well, it starts at 1, goes down through 0, -1, doesn't get back to 1 to here, and it starts at the same place going down again, just like it did here, repeating that same pattern. So its period is also 2 pi. All right, so what are we going to do with this? I don't think a lot of this information is new to you. You guys have had some experience with sines and cosines. I know in geometry you did a little bit of this probably. Maybe not with last year because you might have been the end of the year, so you might have missed out on this. So this may be new to you. We'll discuss that when we get to class. All right, so what are we going to do with this new knowledge we have? They're going to give you problems, and they're going to say things like this. First off, this one is always kind of funny for me. They say find each value by referring. That should be a double R, sorry. My spelling is off. There's something wrong. By referring to the graph of the function. All right, they're going to give you this direction, and then they're going to give you problems, for example, that will be cosine pi. You don't need to look at the graph. I'm going to tell you right now, if they say find it by referring to the graph, I just look at the unit circle. Cosine of pi, this is it. The x value there is what? It's -1, so this is -1. I use my unit circle for all this stuff. So necessarily follow the directions on that. This is just more unit circle practice, right? If you want to, you can use the graph. If that works for you and you like doing that, that's by all means do it. But I just want you to be aware. They ask you to do that. I'm not that worried. The other thing they're going to ask, they're going to say find the values of theta for which each equation is true. Oh, I hate when it does that. All right, so they're going to give you something like this. An equation that'll say sine theta equals 0. Well, how would I figure out where sine theta equals 0? Well, think about it. I'm just going to go back to my unit circle. You can use your graph. I mean, if we go back and they say, and you have a graph drawn of sine theta, where's sine theta equal to 0? Right? Well, it's going to be equal to 0 here, here, here. So it's going to infinitely many answers to this. So how do I, when they say find the values of theta for which this is true, how do I describe all those values? That's the hard part about this one. All right. Well, it starts here at 0. And that's what I always think of is where does it start? And then how often does it happen? It happens every pi, doesn't it? At pi, 2 pi, 3 pi, negative pi. It'll like keep happening that it's back at 0 there. So the way I answer this question, the way they're going to ask you to answer this, is to describe all of those values, infinitely many values. And the basic way I do this is I'll say theta equals, all right, and then I start out, where did it start? It started at 0, right? And then plus pi k. That by saying pi k, I'm saying every k multiple of pi. And what is k? You have to always say this. K is any integer, because integers are counting numbers, right? Positive and negative. So this could be -1, +1, -2, +2. K is any integer. So this would describe the infinitely many places. Now, this is kind of redundant in the fact that we have 0 here. You could have also answered this just by saying theta equals pi k. K is any integer. Now, again, do not skip the step that says k is any integer. You need to make that clear when you put a variable in a solution like that. All right, so that's one example. How could we do another one? Let's do cosine theta equals 1. All right, where does cosine theta equal 1? Let's just do it. All right, cosine theta equals 1. Well, that's going to be at this position on the unit circle, wouldn't it? Because that's the 1, 0. So cosine theta equals 1 there. As we go around, not yet, not yet, not yet. It doesn't get back to 1 in the x direction until it goes one full rotation, right? And then it's going to keep doing it every rotation, both directions. So again, you could do it that way with the unit circle, or I could go back to my cosine graph and say it's equal to 1 here, not again till here at 2 pi, and it's going to keep happening every 2 pi, right? So again, I want to know where it starts and how often it happens. I want to make that clear. That's what I'm doing here. Where does it start? At 0. How often does it happen? Every 2 pi, right? So again, this is where we could skip the 0 if we want, and we can just say theta equals, it's going to be 2 pi k, where k is any integer. All right. So again, just a use for the graph or the unit circle again. Let's do this one. These are the ones that seem to give people more trouble than anything. They're going to ask you to graph, let's say, y equals sine theta for theta between, say, negative 3 pi over 2 and 2 pi. So how do I do this? All right. I've got to figure out a way to figure out what my graph would look like for that. All right, so I'm going to grab a different, let's see, let's copy this one and bring this one over here. So if I paste this one in, I keep doing that. I remember to switch to that. All right, so I have this. Now, what I'm going to do is I am going to remember how this works. If I think of every one of these as pi over 2, since those are our key points, is every pi over 2. If you haven't seen that in the first couple graphs. So this would be pi over 2. This would be pi. This would be 3 pi over 2. And this would be 2 pi. And this says 2 pi. So I'm going to stop there. I'm going to go backwards this way and do it by halves, right? So that's as far as back as I have to go. So now what I do is I just make myself a little cheat sheet. Sine is the y value. So the y value here is 0, then it's 1, then it's 0, then it's negative 1, right? So if I start at 0, I know I'm 0, right? So I put 0, 0 for sine. I know at pi over 2 it's 1, so I'll make that 1. At pi at 0, negative 1 here. I got to scroll up just a touch to get down to negative 1. And you want to always scale your graphs nicely, guys. So this is negative 1. I don't know what I did there. So we got 3 pi over 2, negative 1. And then back at 2 pi, I'm at 0 again. So I'm going to stop there. Now, this one says clearly that it stops there. So I'm not going to make arrows when I go by this. So I have these key points. And now I want to go backwards. Negative pi over 2. Well, negative pi over 2 just means I'm rotating this way. Negative pi over 2 is negative 1. So from here, I go down to negative 1. At negative pi would be up here at 0. And negative 3 pi over 2 would be up here at 1 again. And again, if you notice the pattern, it goes from 0 to 1 to 0 to negative 1 to 0 to 1 to 0 to negative 1. And going backwards, the same idea. It's going from 0 to 1 to 0 to negative 1, 0 to 1. So you can just repeat that pattern if you know where it starts. All right, you don't have to. And again, I'm going to make a nice clear endpoint because it said all the way to negative 3 pi over 2, but no further. So then I do this. Whoops, that curved a little more than I wanted it to. Let me redo that. You want to make nice curves, guys. It's important to represent this, at least. So I go down to there. And then I'm going to Oh, that was horrible. All right, let's do it the way we were meant to. This way. And this way, then down to here, down to there, and up to here and stop. That would be our graph for y equals sine theta between negative 3 pi over 2 and 2 pi. All right, let's do one more. If they ask you to graph y equals cosine theta from negative pi over 2. Oh, well, this should be theta, sorry. Now it looks like the X-Men. All right. Theta. And let's go to 5 pi over 2. All right, if we do this, again, I'm going to get that same graph I had before. And I am going to not draw on it while I move it this time. See, I learned. Let's see, we got this. I'm going to create my cheat sheet again, but now for cosine theta. For cosine theta, cosine is the x's. So x out here is 1, then 0, then -1, then 0. And so I can do everything I want from there. And I can do this. I'm going to do by halves. And go backwards by halves. I only have to go between these two, so I'm going to just go there. And I need to go from 1 to -1, 1 to 1. And again, if I start where you're comfortable. If I start at 0, 0 is 1. So it's here. And what do these graphs do? From 1, this is going to go, when I move forward, it's going to come down to 0, right? And then it's going to go down to -1. It's going to come back to 0, up to 1, and then back to 0, right? This is what they do. They alternate between ones, -1s and 0s, right? So from here, it's at 1. It should be at 0 next. And again, I'm going to make a nice hard finish. This is going to go through there, there. Normally, I'm really good at drawing these curves, but I'm doing it on the tablet for the first time ever, so it's a little ugly. That would be the graph of our y equals cosine theta. All right, and between negative pi over 2 and 5 pi over 2. So you want to know these characteristics. You want to know that I like the little cheat sheet using the unit circle of just figuring out what kind of sine and cosine are just by knowing that the x and y are these values as we go around. I think that is very helpful when you're doing these problems. All right, so those are the things they're going to ask you to do. We're just dealing with the basic sine and cosine graph to start. And we'll expand on this as we go through the next week or so here, week or two. All right, so have a great day. Get your homework done and ask some questions tomorrow. All right, guys. See you then.